Today we'll talk about the input parameter selection for SWAT cop using SWAT algorithm. But before that, we need to follow some steps. From DHM, Department of Hydrology and Meteorology, we obtain Seti station discharge data from 2000 to 2020 of more than 20 years period data. This data we obtain with daily data. Now we need to convert this daily data into monthly. For that, first so this column, three columns. We'll select this and Control Shift drop down menu to select all. Then we will change this into custom and sort date. And we will separate this date using text to column function. We go to data, text to column. First we need to select the data. We go to data, then text to column, then delimited, next, then tab function OK, then other, then we will type here backslash, next, then we will choose the destination, select this, finish, OK. Then we will change this column into text. Control Shift drop down menu, text. This is month, age, year. Step is to draw the pivot table to convert daily discharge into monthly discharge. Then we select this month, days, year also for daily. We go to insert, pivot table, table range OK, new worksheet OK. Then we click here. So here we click here, then we'll bring here row. So for sum, then we'll bring month in column level here. This is month 1 to 12 month, this is year. Then find here, go to value field setting, average value OK. We found the average value from 2000 to 2020 for each month. We only need average value from 2005 to 2015. We select values from 2005 to 2015 only. We copy this and paste special. Here we select transpose, then it will give the values in column order. This is 2015 January all average, February all average value. Then we copy these values one after another in this flow preparation sheet. I have already made on DSM data, observed data, and simulated data. Simulated data means data is obtained when we run the SWAT model. We copy and paste these data from SWAT database. These were flawed values. This is DSM data values. Now we are ready to use these data in SWAT helper. We take this green portion values for calibration. We open the SWAT helper. Here we can find calibration and validation period. This flow data values. Here hydrograph tips is given. Tips statics, various information about input parameter. We can find here. First we go to flow data and enter our first calibration period, that is 1/1/2005. 1/1/5. Then it is already built-in function, so this date as our date might not match. We don't need to worry about that. We can write date here and we can copy and paste here also, but this can also work out. Then we copy observed and simulated observed values. This we copy all calibration period discharge values from here and we paste here observed and simulated values. Similarly, we copy validation period values and copy and paste. We see that last values of calibration period is 24.74. So this is the ending date for calibration period 2/22/2005. So we'll go to calculator and we type start date as 1/1/2005 and ending date as 2/22/2005. 2/22/2005. Similarly, we type the period for validation period, that is 2/23/2005 to 4/18/2005. Here particular year is 2005 as there are data only for 2005 from to start date to end date for calibration, and we can choose here calibration validation period separately. So we'll see here calibration period, and this is the graph we obtained. Here in this graph peak values is higher. For simulated values, peak values is higher than observed values, and base flow values is lower than observed values. This case match with in tips hydrograph. We can see that various types of graphs. So our graph match with issue 4. Peak value is higher and base flow lower. So we'll follow these steps for choosing the input parameters. Here causes high surface flow than reality, lower base flow than reality. Solution, we'll adjust the infiltration parameters. We'll adjust alpha VF values. We'll follow these steps for calibration and validation in SWAT code. In this way, selection of input parameter is done. Also, we can see here NSE values. This is the graph we can find in the Google. This is performance rating of hydrological model given by Morassi. Before calibration, our NSE value is 0.7. This is net short clip efficiency values. 0.7 will lies in here. 0.65 to 0.75. So our model is in good rating. We need to make our model very good rating, so we need to increase the value of NSE. Similarly, we can see the value of RSR 0.55. Here 0.55 lies in very 0.55 also lies in good rating. So here we will decrease the value of RSR and make very good rating for good calibration. Similarly, we can see here p bias percentage bias for stream flow values. We obtain 28.3% plus. This is unsatisfactory values, so we need to decrease the p bias values. So by changing input parameter values, we will make this NSE, RS and p bias values lie in very good rating. This is calibration. Same is the case for validation.